It's speech to text. And, I say that and people are like, wait, speech to text, that usually takes a cloud solution. And they're right. Usually it does. But we can do this not only on device, but we can do it on a CPU. We don't even need a powerful GPU to run this.
Hey everybody, Dave Lindbergh in Hong Kong with another episode of the THD Podcast. Today we're going to learn about wake words and AI on the edge, like how do you get your custom words going and all kinds of different stuff that a company named Sensory has been working on for quite some time. I don't think people realize how long they've been around, so we're going to find out all about them. But without delay, let's give a shout out to Audio Express. And as always, we encourage people to go check out the archives. They've got some stories on Sensory where people can learn more about them if you enjoy what you find out here today. And also the Alti Association. They're going to be at the high-end show in Munich coming up in May here. So we encourage people to go say hello to them. So without delay, okay, we've got Jeff Rogers, the VP of Sales and Marketing from Sensory, joining us today. Good afternoon for you. How's it going?
Good. No, it's great to
Good.
be here. Thanks, David.
Okay, and we've got Simon Weston, our co-host in Sendai, Japan. How's the weather in Sendai today?
Oh, I've got a bit of rain, but at least it's not cold.
Okay, so yeah, Jeff. Uh, Sensory has been around for some time, a little bit under the radar for many years, but now that you've evolved into this, or maybe we'll find out quickly, wake words and edge voice pickup is kind of your specialty, what I know you for. So perhaps maybe let's just get directly into a presentation and not waste anybody's time.
Okay, great. We have been around for more than 25 years. This is our third, we're over 30 years now. So we've been at this a long time, and definitely not under the radar, although a lot of people don't know that it's our technology when they're using it, because we're the technology inside. So let me jump to a presentation here, just to introduce Sensory, and then I want to spend a little time on some demos and really kind of talking through what we can do. So let me just share my screen here and move this black thing out of the way. So just, I guess for starters, we're definitely known as the kings of AI on the edge. We do everything on the edge. Everything that I'm going to show you today runs on the edge. But we're not opposed to hybrid models either. And with the release and the gaining popularity of LLMs, or large language models, there's definitely a play there. And we play really nicely with these, where we can do as much as we can or want to on the edge, and then use the power of large language models or LLMs in the cloud. And so having that hybrid solution is really important and critical. In fact, just yesterday, I saw an article came across my news feed with the CEO of OpenAI, basically saying, when people say please and thank you, it's costing us tens of millions of dollars.
I saw that as well. Yeah.
Oh, did you? Yeah.
Yeah.
That's because everything goes to the cloud. And anytime you go to the cloud, there's a cost associated. And the more people that you have using a system and the longer that they're using it, all of that adds up. So simple please and thank yous, yeah, tens of millions of dollars. So hence doing those types of things on device, wow, it's a far better solution across the board, monetarily, as well as reliability, latency, all those things are going to come into play. So again, what I want to talk about really is AI on the edge.
Okay.
And if I let's start my presentation here. So why Sensory? So we've licensed more than 200 companies around the world, and many of these are huge trillion-dollar companies, and that includes companies like Apple and Amazon and Google and Microsoft and Mazda and Honda and LG and Samsung, Spotify, Zoom, etc. And you can see a lot of the logos here. These are all real customers that have done projects with us, and so we're very different from others in our space in that we do license across a lot of different brands and across different markets. So more than 3 billion products have shipped with our technologies. There's many companies today that are like, oh, I can do a wake word, or oh, I can do speech recognition because I'll do it in the cloud and it's quote unquote easy. It's not hard to do those things, But what gets challenging is to do them really, really well. And it's even more challenging to do them very well and on device. And so a lot goes into, our success with all these big brands that you see here on the right side of the screen. It's got to work in real world environments. I see demos all the time where they're typically videos. And there's a reason that people do videos is because, if it screws up, you edit it and do it again. So let's focus on where we are today and what we're doing. And as you can see, our market focus is we're doing a lot in automotive, we're doing a lot in medical today, and of course a lot in consumer electronics. But then generative AI products are really interesting to us and starting to grow. And the reason our focus is here is all of these have a need and a desire to run on device, or to use a hybrid solution, and that's absolutely where we play. So why on-device AI technology is important? Well, first, what we're providing is a full voice and vision suite of technologies. So this is wake word or wake words. It's speech to text, and I say that, and people are like, wait, speech to text, that usually takes a cloud solution. And they're right, usually it does. But we can do this not only on device, but we can do it on a CPU. We don't even need a powerful GPU to run this, which is amazing. And I'll show you a demo that we've created, or actually a solution that we've created for the automotive market, where it's a complete automotive assistant, and it's all running on device, and it includes full speech to text for dictation, which is awesome. And then also Sound ID. Sound ID, again, in automotive is being used for our siren detection. It's an emergency vehicle detection, or EVD. And as well, there's another company called Intuition Robotics, and they've got a little robot that's designed for senior citizens. It's kind of a companion, and it sits there, and it has a really nice display. I should have brought a video of it to share with you and the listeners here, the watchers. But they did a really neat job. And of course, it's using our wake word and our speech technologies, but they're also using our Sound ID, and they're using our sneeze detection. And so if I'm sitting there in my chair and it's got this like a display / face kind of thing, and if it detects a sneeze, then it says, oh, God bless you, I hope you feel better, kind of thing. And it just brings a naturalness and like a reality level. Oh my gosh, this thing is like really a person here to kind of help and watch and help me, kind of thing. And it's kind of a neat, use of a lot of different sensory technologies all into the same thing. And of course, again, that all runs into this on a little robot that sits on your table next to you. And then we also do face and voice biometrics. Our face biometrics are currently still used in banks today. Our voice biometrics are used in things like PCs and have been used in mobile phones in the past, and a lot of different similar types of applications. And so wrapping those, all those technologies together, we have some customers that use just, the wake words, and others that are using the wake word and the speech to text and Sound ID and biometrics as well. So you can kind of mix and match things. So always on, always available. That's really key. You never need to rely on network connections. And I live in the Portland metro area. So there's 2 million people in the area. It's definitely a large metro area. And yet when I leave my garage, I can use Google in my garage, but as soon as I hit my driveway and get up on the street, I don't have access to Google, voice access to Google, until I drive all the way to the top of the hill and out of the neighborhood. And so there's several minutes of, if I want to do something, I have to do it in the garage, or I have to wait until I'm down the road, because it's too weak. There's like a single bar of connection. And so you can do some things with that, but doing voice over that, forget it. It's just, okay. I can say the wake word and it just sits there and just spins, and it's like, okay, I'm not going to do anything for the next several minutes. So a lot of people say, oh, everyone has access to the internet. Yes, but not all the times. And in the car, for sure, that becomes an issue. And even in home, I mean, my home, the router's upstairs, the TV is downstairs, it's a long ways away, it's to a bunch of different walls and floors and blah, blah, blah. And it's a much weaker connection down there. So if I can do it on device, I don't have to worry about that. More and more people are concerned about data privacy and control. And if you have an Amazon smart speaker in your house, which I do, I think they're great. I use it all the time. You can go to your Amazon account and you can log in and you can actually see and hear everything that was accidentally recorded and sent to Amazon. It's kind of freaky. So you can hear conversations, because you don't know when these things are false firing, because the little light ring, does its thing, and then it listens for a bit. And then, on the cloud, they determine, oh, this wasn't meant for Amazon, which is fine. But they still have that recording. So you still have recordings leaving your home. With Sensory and with on device, it's complete privacy. There's, everything stays on device, runs on device. And most of our customers today don't have a connection to the internet at all, in things like, GoPro smart, sports cameras and Garmin dash cams and stuff like that. They just don't have that connectivity anyway. But if we do have that, for example, Tele TV, which is a new TV, which is really amazing. They're using our wake word, they're using our speech to text, and they also have a cloud connection, because there's media and other things that you're streaming. And so for products like that, there is an option to use that data to improve models, et cetera. But my point is, it's completely up to the customer. They get to decide that, which I think is great.
Just maybe tangentially to that, has the policies with Amazon Alexa changed at all? Because I'm very aware of the factory that builds a lot of these things, and I know when they're doing third-party products, some of the brand customers that would incorporate Alexa were asking about, can we have privacy on the data? And that basically the answer from Amazon was that conversation is not available. Has that changed at all on their side?
That's a good, I've heard that as well. It hasn't changed as far as I know, but I also don't follow it that closely. A couple, in the past, you noticed that Amazon was one of our customers, and in the past they licensed our technology to run on some of their products directly. And then Amazon said, hey, we got our own wake word now. We don't need Sensory anymore. And so then they started providing their wake word. Well, they realized that doing that is a big pain in the butt. And then they realized, wow, we're losing, I don't know, $20 billion or some huge number on all these third-party products that are being created that can connect to Alexa. And so I think it was a year or 2 years ago, they said, no more our products connecting to Alexa. And so it really left a lot of companies kind of high and dry. Oh my gosh, what are we going to do? And some of those we're working with now, large appliance companies and others, where they used to rely on Amazon and Alexa, but they've realized that, hey, a cloud partner, particularly these large companies, they can change their business model at any time, and then they're just left high and dry. And with Sensory, again, because it runs on device, hey, once it's in there, it's in there. We're not going to shut it off. It's not going to shut off. It's going to keep running. But on the privacy thing, I've heard similar things. And with Sensory, it's just a non-issue, because, hey, everything runs on device.
Yeah. So people just talk to you if that's an issue.
Yeah, absolutely. Right.
Yeah.
And then a lot of flexibility. I mentioned that everything can run on the CPU. We can run on GPUs if we wanted to take advantage of that, or new MPUs. But we can also run deeply embedded. We have a very large European automotive OEM that will start shipping vehicles this year, and they're running multiple wake words on a DSP. And then Sensory is used as the arbitrator between, hey, am I going to go to one of these cloud engines like a Siri or a Google or an Amazon, as an example, or to the local assistant that's running in the car? And so in some cases, they'll be running 4 to 8 different wake words all at the same time, so that people don't have to pick. When you get in the car, I have an Android phone, and so I'm going to go to Android Play. And of course, my kids have iPhones, because you can't be a kid and not have an iPhone. And so they want to go to Apple Play, right? So in the case of Sensory, we can actually run multiple wake words at the same time in the vehicle, so that people don't have to pick and choose. And so for me, and maybe I want to go to Amazon, their automotive solution, so I can say Alexa, and that would use Sensory's wake word for that, or Siri, and Sensory also provides that. As I mentioned, Honda and Mazda today are using our Siri in the car, kind of thing. So the ability to run multiple wake words is becoming more and more important and interesting. And then again, we can also run those deeply embedded. Cost is another thing I mentioned. When we started out, I was talking about that article of the CEO of OpenAI saying, please and thank you are costing us, millions of dollars. Stop doing that kind of thing. With Sensory, there's no cloud infrastructure required. We can do OT, over-the-air updates if that's designed into the product. So there's still a lot of flexibility there. And then finally, we're market proven. A lot of different languages, a lot of different custom solutions, more than 3 billion products. Yeah, we got something that works really, really well. Otherwise, we'd never have 3 billion products that are using our technology.
Mm-hmm.
So markets, automotive, I've talked a little bit about that already. Medical, we're doing more and more in medical with companies like Stryker and Edwards Life Sciences, who just got acquired. I can't remember the name of the company that acquired them, but these are multi-billion-dollar companies. There's another one called Norlace, which has an eye laser surgeon device. And before Sensory, the surgeon had to put down the utensil they were holding and reach over to a tablet and make changes. And now it's all voice controlled. So medical is important to us, and it's also important for speech because
sorry, Jeff, is that in a surgical application that they're adding control function with voice?
It is, but they're not using voice for anything like,
Incisions.
turn the laser on or anything like that. It's more for simple settings.
Okay.
Yeah, good question. In the case of Stryker, it's they're using us in a like a pendulum that nurses wear around their neck, and so it makes it hands-free. So you can talk to it without having to touch it, kind of thing.
Okay.
And then with Edwards Life Sciences, it's I can't remember the name of the device, but it's a device that goes into hospital rooms. And again, rather than walking over and twisting knobs and pushing buttons and blah, 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 you just talk to these things. And again, the reason medical really likes Sensory is that we run on device. And so there's no, HIPAA is a really big issue with anything medical. And anything going to the cloud, you've got to do a lot of work to make sure it's very private and protected. Here, nothing ever leaves the room or the device, and so it makes it really pretty special. The other ones, consumer and home electronics, we're doing a lot there. I did a webinar with the partner that you mentioned earlier, where it was all about what I called the home hub. And with Amazon, changing the way they were doing business, my suggestion there is, hey, we can do a complete home assistant that runs on device. And so I can have the wake word in the satellite products. I can have our speech to text running in this home hub. And that also has the NLU in it. And then just using Zigbee or Wi-Fi or Bluetooth or Matter or whatever, you have this communication to actually control devices. And you can do all this without buying into an ecosystem like an Amazon or a Google or a Siri, as an example. And I think it's pretty interesting. Mobile, tablet, and PC, we've always worked in these industries. Same with wearables and hearables and Bluetooth, and again, being able to run really, really small is really important, and that's where we have a very strong play there.
Mm-hmm.
Okay. So wake word and phrase recognition. I wanted to show a little video here, and I hope this shows through here. This is from the Sonosite Voice Assist, and they're another one in the medical space that are using Sensory. And so again, our truly hands-free allows for a wake word as well as these phrase spotted commands. And so what you're going to see in the video here is what they've done, what Sonosite's done. It's a really neat product, and you'll see the value that it provides to them. So hopefully this will come through. Let me know if you don't hear it, because I don't know if I did the correct setting to share the audio. Okay. So yeah, what you're going to see in the video is doctors and surgeons that are talking to I forget the name of the device. Why can't I think of it? And so scanning, and what they're doing is they just talk to it. So they say a wake word, and then they can just say command after command after ultrasound. That's the product I'm trying to find there. Mm-hmm. And so it's a very natural kind of interface. So let me play this through.
Activate voice. That's really fast. Centerline on.
Next. It makes an easy to use machine even easier.
This is perfect.
Fujifilm Sonosite Voice Assist. Redefining ease of use.
You can imagine this like even enabling a more hands-free kind of sterile environment.
All the time I got sterile gloves on both hands, so I have no ability to do this without an assistant there.
It actually frees up a lot of things. Color off, centerline on. Whoa, okay. That's super responsive.
I've got a ventilator, I've got a dialysis unit, sometimes I have an ECMO machine, and trying to figure out where I put this is basically, it's the last thing in the room, so it's going wherever there's space for it.
This could be further away and you could still have pretty good control. And so that way you get more access to the patient and still have total control of your ultrasound. I think that's really cool.
Reduced depth. Perfect. I think this is so clearly something that we need. If I'm already turning off my lights at home and turning on my oven with my voice commands, it should be expected that we'd be able to do the same thing with medical devices.
It's surprisingly fast and responsive. Sometimes voice activation complicates things, but I feel like this one simplifies it.
You can't do your job without an ultrasound that works. This is the one that just keeps working and working and working day after day, year after year.
Let's just play around with it. Activate voice, center line off, color on. Yeah, this is cool. And then I would imagine, yeah, this works exactly like I would expect it to. So that's Sonosite right there.
It's on YouTube, but it's a nice little example of, truly hands-free in this case, all running on device.
Okay.
So moving forward, our truly natural speech to text is one of our newer technologies. So it's embedded, it's large vocabulary, it's full on dictation. So again, I don't have to worry about a cloud delay. We can have generic or domain specific language models. And the demo I'm going to show you in just a minute is what we've done in automotive, but also show some other domains as well that we've created. It's customizable. So size, platform, a grammar versus a small language model versus totally embedded versus a hybrid solution, natural speech, so full speech to text combined with a micro language model. And that micro language model really is designed to pull out the intents of and entities of what you've seen, what you've said. Now, this is where,
if you don't mind, when you say large vocabulary, what's large and what's small?
Yeah, it's a good question. So with full-on speech to text, you can say anything, right? There's no definition around, there's 20 words or 100 words or 10,000 words. Whereas with our Truly Natural Lights, we have two different products. One called Truly Natural Speech to Text, which is full-on speech to text. So there really is no size because it's full. You say anything you want, it's going to recognize it. And you really need to have an NLU or this micro language model that basically pulls the intent and entity of what you said and then does something with that. And then we also have our Truly Natural Light technology, which is a grammar-based approach. So here you define it, and I've got an example that I'll show you in just a minute where I was talking to a company that makes smart boards. And they're like, hey, we'd really like to add speech to a smart board, but it's all got to run in 2 megabytes of RAM, 2 megabytes of memory. So it's got to be really, really small, but we still want natural language. Well, that's where our Truly Natural Light comes in because it's a grammar-based approach. And so I'll show you the tool that we've created that allows developers to create these things on their own. But basically, I just created kind of a quick Truly Natural Light project in this tool called VoiceHub. And it allows me to define the intent and the entity and basically, the grammar. But in that, it's really important that you define the grammar clearly so that it includes all the things that might be said. Whereas with Truly Natural Speech to Text, I can virtually say anything. And then it's that micro language model that dissects it and says, okay, here's what you meant. And then it passes it on to the system. So yeah, good question. And then again, you're tired of hearing me say this, private and secure, totally runs on device. I'll leave that one alone now. So here's an example of either running completely on device or a hybrid where we're using an LLM. So this is, for an example, in my home hub idea where I want to do a full assistant in the home. So first off, you have the audio source. That's the person talking. And then the wake word model. So ultra low power listening for key wake word. This can run at a DSP. It could run on an M4 and even an M0 based thing, the custom DSP, or on a full application processor. Doesn't matter. So here I can say, hey, wake word. And again, this can be custom. I used to tell people, companies, stop giving your brand away to Amazon and Google. I think that's crazy. Why would you do that? I mean, Kohler came out with a whole line of faucets, and what did you say to it? Okay, Google, blah, blah, blah. I'm like, what? Why not? Hey, Kohler, build and protect your own brand kind of thing. So the wake word can be custom. We support 3 different types of wake words. It can be a fixed wake word where it works right out of the box. That's the most common. It can be a user-defined wake word where the user defines their own wake word. I want to call it whatever I want to call it. And then we also support an enroll fixed wake word. A good example of that's anytime you get a new iPhone, you have to say, hey, Siri 6 times. That's because the phone is learning how you say, hey, Siri. So that's an enroll fixed wake word, and we support all 3 of those options. Next is the acoustic model. So this is basically what I'm saying. This is the language that I'm speaking. So, it understands sounds from the language. So in my case, it'd be US English, but we support 35 different languages. And so here the example is set the temperature in the bedroom for 67 degrees. And then the language model, so this can also run locally, and this is what we're doing in automotive as well as TV and hospitality and others that I can show you in a minute. This is basically where it's everything that I might say to that, and we design it around that so that there's more intelligence and kind of statistically relevant weighting towards the things that I might be saying. And that it also means that if there's a false fire on the wake word, and then something else happens, the language model is going to catch the fact that, oh, this wasn't meant for me, and it can just ignore it, kind of thing. So it's really powerful and important to have. The next step is either a small language model that can run totally on device, or going to the cloud and using an LM, a large language model. And both of those are really interesting. A small language model, we did one for a Honda Accord 2024 user's manual, where instead of having this big fat manual where you've got a question about, what kind of oil should I put in the car? How do I change my wiper blades or whatever? How do I program my garage door opener? That's a key one people look up. How do I program my phone or add my phone to Bluetooth, whatever? So we took that big fat user's manual and digested that whole thing down into a small language model. And the whole thing runs on device now, and at a size of 1.8 gigabytes. That includes the small language model, the automotive language model, the acoustic model, all those things in that. And then again, the other option is that instead of doing this work here of the language model and the SLM, we just take everything to the cloud and say, all right, cloud. And LMs are very good at figuring out, you can do a little bit of prompt engineering and saying, you're a home assistant, you'll basically identify intents and entities and then give me something back. And so if the user says something like, yeah, I want to set the temperature in the bedroom to 68 degrees. You know what, 68 might be a little warm. Let's go with 65. 65. Let's just go with 67 degrees. The LLM is really good at listening to all that garbage and saying, all right, the intent was to set the temperature and the entity was 67 degrees. It forgets about all the other stuff. So that's where a hybrid solution becomes really interesting. And we play nicely into that because the wake word, the speech to text, all those technologies run on device, and then we just go to the cloud for the LM. And all we're sending to the LM is just the text information. So it's like 600 times less data than sending the full voice there. And so again, from a cost perspective, way less expensive to do it that way. And then lastly, you get the feedback from the SLM or the LM with, okay, what am I supposed to do? And then the output can, speak, better temperature set to 67 degrees. So everything in this box here can all run on device unless we want to go to the cloud and take advantage of an LM here. And if we want, some of the cloud solutions for text to speech are just, they sound really amazing. They sound like real human speech. Those, again, probably go to the cloud for those things as well. So having that hybrid is pretty interesting. Let me go through how we're doing on time here. This has been a pretty fun conversation. Let me just quickly go through a few more, and then I want to jump into some quick demos here. Sure. I mentioned our sound identification and emergency vehicle detection. This is being designed into automotive right now. The idea is that, we can filter out more than 99.5% of the non-siren sounds, and when the internal microphones in the car hear a siren, it can alert the user. And so as autonomous vehicles become more and more popular, this will be a mandate. It'll be a requirement. Europe's already talking about this, but also to help the user understand if they're listening to loud music or something, we can identify that and say, hey, there's an emergency vehicle in the area. But then we can do other things, as I mentioned, the intuition robotics that are using our sneeze detector, but we can do baby cry and dog bark and glass break and horn honking and water running and coughs and sneezes and snores and that sort of thing. Face and voice biometrics, I talked about this a little bit already. Runs totally on device. It's very fast. Our real-time voice ID, always on. And we support both text dependent, which is basically an enrolled voice password, as well as text independent, where I just, as I'm talking right now, it says, oh, that's Jeff talking, and it can then, verify me with that. And so both of those are pretty interesting. And we're seeing a lot of interest right now in a variety of markets for our text independent speaker verification, because it can, just based on me talking, it can say, oh, that's Jeff. Now go do something based on Jeff talking.
Yeah.
Let me, just a quick shot of languages that are supported today and in development. This is all for our truly natural speech to text languages. So you can see there's a bunch of languages here. And then this is actually a little outdated. It says with models as small as 35 megabytes, today we're down to 10 megabytes on some of these models. So it's getting really interesting on what we can do in 10 megabytes with a more domain specific speech to text model. So this is an example. Can you see the screen okay?
Yeah.
Okay. So this is our VoiceHub tool. It's really, really powerful. And you can see this is the VoiceHub Pro, which is the next generation. So I can create a single wake word. I can create a series of wake words. I can create a command set project and pull in a wake word. And then I can also do a truly natural light grammar project as well. So here, I've got a dishwasher, and now I'm getting older. I can't see the tiny little text on the, that's 0.6 font. And so I've got to, put my glasses on and see which button to push. So what I did is I said, you know what I should do is let me just, and I'll make this a little bit bigger here. Maybe that'll help see it a little bit more. So these are all the buttons that are on my dishwasher: Pro Wash, Tough, Normal, Light, Express Wash, etc. And so I just typed all those into this tool. And here I also grabbed a 200 kbyte wake word that's a kind of a standard one. I'm using the English, US English, and you can see there's a lot of different languages that are part of VoiceHub as well.
Mm-hmm.
The size that I want, this is designed for a Cortex M55, U55. And actually what I really want is just the standard SDK right here. And then you can see that I can do either prototype or I can do best quality. And then I can also do, I can change the operating point. An operating point is basically a balance between false accept and false reject, where a point of 1 means very low false accept and higher false reject. And a 21, so it goes from 1 to 21. A 21 is very low false reject and a higher false accept. So there's always that balance between them. So because I just changed this to the sensory SDK, it's going to have to rebuild. Hopefully this just takes a minute to do it. But while it's doing that, let me, it's done. Okay. So the next thing I'm going to do is on my phone here, and I'll just screen share my phone. And I'll launch VoiceHub. And then I'll pull my phone over into here. Okay, just give me a second. Scan the QR code. So here's my phone.
Mm-hmm.
So I'm going to go download the model. And then where did my phone go here? So if I just scan that QR code, there it goes. And now I have, why is this kind of hard with this? Okay, now I have this project here now running in my phone. So now I can test on the PC, or I can test it directly on my phone. So you can see I'm talking. Here's the wake word. Here are the commands. So I don't have to hold the phone right here. I can put it just down on my desk here, and I can do the engineering test where I say Voice Genie Pro Wash. And down below, you can see it recognize it. Great. But that's not reality. The way people are going to say this is they're going to say, okay, yeah, Voice Genie, I want Pro Wash right now. And even though I said something before the wake word, something after the wake word, something before the command set, something after the command, I was saying, I spoke quickly, mushed it all together, it still got it. Mm-hmm. And so that makes it really powerful. Things like Voice Genie, 4-hour delay. the doesn't destroy us, and that can destroy speech engines. And then simple things like I've got everything ready to go. I just say Voice Genie start, and it just recognizes it, and the dishwasher's off and running. I mean, that's amazing. That's so much easier than walking over and finding the right buttons and hitting this, Voice Genie cancel. And, now I've just canceled the washing. So I created this whole demo and this project. It took me like 5 minutes to type it in maybe. And then it built over probably 4 or 5 hours because it's building that flexibility or that balance between false accepts and false rejects. And then I've got something where, because this is downloaded or built for our SDK, I can actually grab that model and design it into something really quickly. So for proof of concept and even products, VoiceHub output is being used in, I think, 5 or 6 products today that are on the market where they said, hey, this is good enough. I don't have to go out and do the old school approach of recording and hand tuning. Now, we still do that for a lot of customers, but for POCs and for some products, this is great.
Wow, it's impressive.
Can I just ask, that dialogue that was showing us you can see a little VU meter and showing the result. Yes. So is this running on your PC? Is it running on your phone? I missed that point. That's actually running on the phone.
Running on the phone. And I'm just screen sharing the phone. Yeah.
So that dialogue is the phone screen share?
This is the phone that I'm moving right here. This is the phone. Yeah. And I'm just screen sharing the phone.
Okay. And so you downloaded something to the phone. Is it full application or it's some part of an application?
Yeah, good question. So if I don't already have, so if I'm new to VoiceHub, the first thing I can do is I get VoiceHub, I get logged in, and then I can choose which application. Am I an Android user or iOS? And so if in my case, I'm Android. So I just click that, I scan that, it loads an application into my phone. That's the VoiceHub application. Or I can do the same for iOS. And then once I have it, then that's what you're seeing right here. This is an application that's running on my phone right here. And all I have to do is just go and I scan the QR code right there, and that's going to load that. And so what you saw is it loaded the model in very quickly. So again, so when I hit download, it pops up this QR code. Yeah. And then on my phone, I hit scan QR code, and boop, it just loads it in.
Yep. And so that's kind of running in an interpreted environment or something, is it, within that application, the model?
It's the real model. So you can see the total size is 519 kbytes for everything. So that's the wake word that was 200 kbytes. It's the command set with 10 or whatever number of commands that are in there. And so what you're running is what it would be in the real product as well. So it's not taking advantage of the power of the mobile phone and doing all that. It really is just, hey, this is what it's like. Here's a small model, and this VoiceHub application is emulating the same thing that you would find if you're actually running this in a real dishwasher.
Okay, I guess I'm getting at the point is when you, in this case, you're running within an operating system, Android or iOS. When you're doing it on an actual dishwasher, you probably don't have an operating system, or you have an embedded system, essentially.
Correct. Correct. Yeah,
so is there another layer? You need to construct another layer of generating microphone inputs, et cetera, et cetera?
Really good question. Yeah. So here, I just use the output format for our truly hands-free, TrulyNatural Lite SDK, because that's what's running in Android. But you can see that there's these truly hands-free micro models. And so there's a whole bunch of different ones here, but generally, this is going to run on any hi-fi based DSP, any chip that's got a hi-fi 3 or 4 or 5 as an example, or Cortex M series. So if I'm running on an M4, there is no OS. I'm just running in an RTOS. This will format and create that file such that it's designed and ready for, and we run across more than 20 different chip platforms today, and so it's already formatted for that. Yeah, really cool.
Yep.
So here's just a quick example of a TrulyNatural Lite grammar. So this, as I mentioned, this is a smartboard little project that I did. And here I define different intents, board control, brightness, color, input, lesson. And then the slots are basically a group of things that you might say. So think of these as like a bucket of different things. So I've got board control. And so underneath here, I can see, and I just typed all this stuff in: enable power save, disable power save, sleep, wake up, start meeting, show, whatever. And you can see this is page 1 of 1. I can have hundreds or thousands of pages. So this, when you asked earlier, what's the size? Well, you'll see in a minute that this little simple grammar I did still has, more than a few thousand things that you could say based on, once I build it, kind of thing. So, I basically define all the different things that I might want to say, and then down here I just drag and drop these slots that are already populated down into the phrases. So, board control. So I've got intro to board control. So it's things like please, change, I want to, whatever. I just made those things up. And then you can see, please, please, and the question mark means that the preceding slot or word is optional, so I don't have to say that. And I could just say start meeting or start lesson or whatever whatever was under that slot. And so I've got different inputs. I want to change input to HDMI2 as an example. I want to change the brightness, or I want to change the pen color, or I want to select a lesson that's designed for the smartboard. So I just kind of make all that up and just drag it in here and create it. I build it, and this builds very quickly. And so once I hit the coverage, you can see it randomly generates a list of things based on that grammar above. Science lesson, switch green pen, set brightness to high. And these are auto-generated out of that grammar. And so you can see that there's hundreds of different things that are, here. And then I can even type in something down here to say, is this one in here, like HDMI2? And just that by itself is not in the vocabulary because it's listening for, you know what? That's because I spelled it wrong. There we go.
Yeah.
Oh, that's interesting because it's right here.
No, the spacing is different.
Oh, it is. I'm surprised that would matter in here.
Okay.
It shouldn't. Yep, that mattered.
Would it because it's looking for like a cluster, like rather than HDMI, it's looking for a word that would HDMI or whatever would be if it was is that an issue there?
Yeah, so good question. So let me see what I did here. That is, what is that under? That's under input select. So if I didn't put the space in there, it would think I was trying to say hit me.
Yeah. Right.
And so I put the space in there so it knows it's HDMI. And I could also put periods in there. And so that yeah, it was that was a user error on the checking grammar. But the point is you create this grammar and then you build it, and then you can look at the examples here, and then you can check it down here and just type things in and say, yeah, is that there or not there, which is really good. And then same thing, I can test it on the PC right here, or I can download it to my device. So let's do that, just because that's pretty fun. So here's my device. I got to download the model. So you can see this model is 6 megabytes, and that's because I used probably a really large model file. So then if I go to my phone here and scan the QR code, that scans it in. And now that whole file is in my phone now, and you can see it gives me the options here as well. And so here's the wake word. So I can just say things like, hey, smartboard, I want to show home screen. So here it shows the result. I want to show home screen, and it gives me the NLU. Okay, it's board control, and what is it? It's to show the home screen. Or hey, smart screen, switch to HDMI 2. No problem.
Mm-hmm.
Hey, smartboard, set brightness to medium. Hey, smartboard, select writing lesson. So the idea is that, a teacher would be very easy. You've got the smartboard there, and you can just say what you want to do, and you don't have to, touch kind of thing.
Mm-hmm.
So this is our VoiceHub tool, as well as demos of our Truly hands-free and our Truly Natural Light. If we've got just a couple more minutes, I'll show a quick example of our Truly Natural speech to text. David, have we got time for that?
Yeah, sure.
I find it really interesting that in the presentation, it's become weighted towards implementation of this system, which seems interesting in the sense that other people that I've talked to about it, they're talking a lot about how you might train the model and things like that. Seems as though that part of it is very well developed now, and the frontier is enabling people to make implementations as effortlessly as possible.
Mm-hmm.
Absolutely. Yeah, it's a good comment. I appreciate you calling that out. It's very mature. The technology is very mature and well proven, where we don't have to, spend as much time thinking about, the nuts and bolts of the technology. So lots of different languages that are supported in here. I had that list earlier, and you can see them that I can select from here. We'll stick with English. I'll start with the automotive domain because it's just really interesting. And what we've done is developed a complete automotive assistant. And you can see different sizes here: 50 megabytes, 91 megabytes, 227 megabytes, or these with small language models. Whoops. Let me, sometimes the screen share dies on me there.
Do you think you're mostly targeting devices that run off a main supply, like larger appliances or cars which have a relatively high amount of power supply, as opposed to more battery-powered devices like earbuds and headphones?
Yeah, it's a good question. So our TrulyNatural speech-to-text is really designed more for cars and TVs and PCs and things that have a more powerful processor. Whereas our Truly Hands-Free is ideal for wearables and things that have very small chips and processors. Okay, so I've got the demo running here again. So English, automotive, I mentioned the different sizes. So I'm going to start with a really small one, just 50 megabytes. So that 50 megabytes includes the acoustic model, the language model, the micro language model, which handles the NLU, and even an action lookup table. So there's a lot packed into that 50 megabytes. That's really, really small, by the way. I'll just use our standard wake word here. I can get rid of the examples and the models so we have a little more screen. So it's listening for me to say the wake word, and then I can say anything that I would say to a car. So I can say things like, voice genie, roll down the front windows.
Opening the front windows.
And here you can see the recognition result, and then you can see that NLU result. I kind of like the switching to dialogue because it kind of shows this is what I said and this is what the system said. And you see this is the system action LUT, that's the lookup table. And I can say things like, voice genie, turn on the front seat warmers.
Turning on front seat warmers.
I was at an automotive OEM a few weeks ago in Detroit, and one of the guys said, hey, I call those the butt warmers. And I'm like, okay. And I said, voice genie, turn on the front butt warmers.
Turning on front seat warmers.
So, I mean, it recognized it, right? That's the micro language model that's handling that. So it understood what that meant. And I can, whether I say, voice genie, switch on the front wipers.
Turning on front wipers.
Or voice genie, turn on the front windshield wipers.
Turning on front wipers.
So it's just, the intent is the same, even though I said it different ways. And the whole point here is we don't want the user to have to memorize the grammar of the script. Just talk to your car. I mean, when I take my wife's car through the car wash, I literally have to push a series of about 10 buttons. I have to select over to the settings option on the steering wheel, and then I have to go down to the parking sensors, then I have to go over to those. I have to toggle on off. It'd be so much easier just to say, voice genie, turn off the parking sensors.
Disabling parking assistant.
That's a million times easier. Or voice genie, it's too warm in here.
Lowering temperature.
Great, perfect. But I can be more specific. Voice genie, set the temperature to 67 degrees.
Setting temperature to 67.
And I mentioned that this is full-on dictation. So, and with the language model, it can ignore things that don't make sense. So I can say, voice genie, yeah, I'm talking right now and doing this awesome webinar, and we're having a great conversation about how cool this technology is and what we can do. And you can see that this is typing out what I'm saying. And then it just ignored it because it knows that's not something I'm supposed to be listening for. But if I say something like, voice genie, send a message to Todd, let him know that I'll call him later this evening, probably around 7:30.
Sending message to Todd.
So it understood that because I said send a message, and then it's actually trying to send that message, which is super, super cool.
Todd's the boss, right?
Yeah, that's right. That's right. So this is all totally running in the Android tablet, and this is running on a CPU, so not GPU. And it's just amazing what we can do today. And this is with a 50 megabyte model, and as I mentioned, we can now get as small as 10 megabytes. So there's a lot that's packed in here, and a lot we can do. And then we can, as I mentioned, we can also take advantage of LLMs. And we're out of time, but I have another demo where I can run the wake word local, I can run the speech to text local, and then everything goes to the LLM in the cloud. And I can pick between ChatGPT or Pi or Cohere, whatever, it doesn't matter to us. And then just get that back from the LLM. So that hybrid solution is really important to us.
Okay. All right. Any final questions, Simon, before we say goodbye?
No, I think very impressive.
Yeah, it is super impressive, Jeff. Thanks for your time. We'll put some details on where people can find Sensory online and please add comments and questions below, and like, subscribe, all that good stuff. And once again, Jeff, thanks for joining us, and we'll see everybody on the next episode.
No, it's been my pleasure. Thanks so much. And I will send you the link to that video that I was trying to show, so that you can, if people are interested in hearing the actual what's being said, they can see that as well.
Sure thing. Okay. Bye, everybody.